Good morning, everyone. I am Engineer Suman Lata, Assistant Professor, Computer Science and Engineering Department, Maharaja Agrasen University. Today, I am going to discuss memory organization. In previous lecture, we have already discussed the topic computer register. The memory organization topic comes from the subject computer organization and architecture. So, let's start. The memory organization include memory hierarchy, main memory, auxiliary memory, and cache memory. Memory hierarchy. As in the computer system design, memory hierarchy is an enhancement to organize the memory such that it can minimize the access time. The figure below clearly demonstrates the different level of memory hierarchy. The memory hierarchy levels are level 0, level 1, level 2, level 3, level 4. At level 0, CPU registers are there. At level 1, cache memory. At level 2, main memory is there. Level 0, level 1 and level 2 memories collectively can also be called as internal memory. At level 3, magnetic disk. At level 4, optical disk, magnetic tape. Level 3 and level 4 collectively also known as external memory. As the diagram showing the different memory organized in the pyramid way, here the diagram shows when we move from top to bottom, level 0 to level 4 in the memory hierarchy, then capacity and access time increased. And when we move from bottom to top, it means from level 4 to level 0 in the memory hierarchy, the cost bit is increasing. Memory hierarchy. This memory hierarchy design is divided into two main types. As I have already discussed in previous slide, there are two categories in the memory hierarchy. External memory, which is also known as secondary memory or auxiliary memory. And the second category is internal memory, or we can say the primary memory. External memory basically comprising of magnetic disk, optical disk, magnetic tape, peripherals, storage devices which are accessible by the processor via I/O module. Internal memory or primary memory basically comprising of main memory, cache memory and CPU registers. This is directly accessible by the processor. That's why these three level 0, level 1 and level 2 memory are also known as internal memories because CPU has direct access to these memories. There are typically 4 levels of memory in a memory hierarchy. First level or level 0 is registers. Registers are basically the internal buffer area inside the CPU. Registers are made up of flip-flops. Registers are small, high-speed memory units located in the CPU. They are used to store the most frequently used instructions. As the registers are located inside the CPU itself, registers have the fastest access time and have smaller storage capacity, typically ranging from 16 to 64 bits. And this part, that is register, is the internal in the CPU, so it costs very much. Next category, in the next level, level 1, the memory is cache memory. Cache memory is a small, fast unit located close to the CPU. It stores frequently used data and instructions that have been recently accessed from the main memory. Cache memory is designed to minimize the time it takes to access data by providing the CPU with quick access to frequently used data. Cache memory is the fastest memory and its speed maximally not mismatch with the CPU. It is compatible with the CPU so that it is called as fastest memory, and computer CPU directly communicate with the cache memory. Other memory is main memory. Main memory also known as RAM, random access memory. Random access memory is the primary memory of a computer system. It has a larger storage capacity than cache memory, but it is slower than cache memory. Main memory is used to store data and instruction that are currently in use by the CPU. Main memory is basically of two types depending upon the technology. One is static RAM and another is dynamic RAM. Static RAM. As the name indicates, it stores the prime binary information in a flip-flops and information remains valid until power is supplied. It has faster access time and is used in implementing cache memory. So the level 1 memory, which was the cache memory, is made up of SRAM or static RAM. SRAM or static RAM, the building blocks are flip-flops and data remains until power is supplied, and it is the fastest memory. SRAM memory is more costlier and data is remain until power is on. But here no refreshing mechanism is required in SRAM. The building block of cache memory is static RAM. Second is dynamic RAM. Dynamic RAM is the simply random access memory. It also stores the binary information as a charge on the capacitor. It requires refreshing circuitry to maintain the charge on the capacitors after few milliseconds, because as the building block of dynamic RAM are capacitors, frequently the data stored in the capacitors in the form of charges that is discharged after few milliseconds. So a refreshing mechanism is required. It contains more memory cells per unit area as compared to SRAM. Dynamic RAM is less costly than SRAM, but it is slower than SRAM or cache memory. CPU directly access firstly the data inside its registers, secondly the cache, and at the third level or level 2 it access the data from the RAM if the data is not present in the cache memory. The next memory is secondary storage. Secondary storage include hard disk drives and solid state drives. It is a non-volatile memory unit that has a larger storage capacity than main memory. It is used to store data and instructions that are not currently in use by the CPU. Secondary storage has the slowest access time and is typically the least expensive type of memory in the memory hierarchy. Memory hierarchy. In memory hierarchy, we can infer the following characteristics of memory hierarchy design from the above figure. In the figure where CPU registers at level 0, cache memory at level 1, RAM at level 2, and external memories at level 3, 4. Capacity first is the uh, characteristic. It is the global volume of information the memory can store. Capacity basically the total amount of information a memory can store. As we move from top to bottom in the hierarchy, the capacity increases. It means the size of the memory increases from top to bottom. Second is access time. It is the time interval between the read-write request and the availability of data. As we move from the top to bottom in the hierarchy, the access time increases. It means CPU take less time to access data from its registers, then some more time from register if data want to uh, access from the cache memory. But when we go downward, the access time increases. Third is performance. Earlier, when the computer system was designed without memory hierarchy design, the speed gap increases between the CPU registers and main memory due to the large difference in the access time. This results in lower performance of the system and thus enhancement was required. Memory hierarchy is the enhancement because in this design, performance of the system increases. One of the most significant way to increase system performance is minimizing how far down the memory hierarchy one has to go to manipulate data. Cost per bit. As we move from bottom to top in the hierarchy, the cost per bit increases. Internal memory is costlier than external memory. Internal memory are registers, caches, and main memory, as I have discussed in my previous slides. The memory unit that communicates directly with the CPU is called the main memory, as in the diagram below in the slide showing CPU is directly accessing cache memory and cache memory is taking data from main memory. CPU is also directly connected to main memory. If the data is present in the cache which is required by the CPU, then cache hit is produced. If data required by the CPU is not present in cache, the cache memory takes the data from main memory and further CPU can take the data from cache memory, or In other case, CPU directly can access data from the main memory. If data are not present both in cache and main memory, then main memory has to request to IO processor and data can be taken from the permanent storage or secondary storage memories, which can be magnetic disks or magnetic tapes. Devices that provide backup storage are also called as auxiliary memories. The most common auxiliary memory devices used in computer systems are magnetic disks and tapes. The total memory capacity of a computer can be visualized as being a hierarchy of components. The memory hierarchy system consists of all storage devices employed in a computer system, from the slow but high capacity auxiliary memory to a relatively faster main memory to an even smaller cache memory. Cache memory is high-speed memory used to increase the speed of processing by making currently required instruction available at the area of cache memory. The main memory is the central storage unit in the computer system. It is a relatively large and fast memory used to store programs and data during the computer operation. The principal technology used for main memory is based on semiconductor ICs or integrated circuits. Integrated circuit RAM chips are available in two possible operating modes, as I have already discussed: static and dynamic. Static random access memory, SRAM. Here data is stored in the form of transistors and required a constant power flow. Because of the continuous power, SRAM does not need to be refreshed to remember the data being stored. SRAM is called static as no change or action or refreshing mechanism is required or needed to keep the data intact. It is used in cache memories. Advantages of static RAM, or we can say the characteristics of cache memory is: cache memory is much faster than DRAM because cache memory is made up of SRAM. So we can also say static RAM is much faster than DRAM. Static RAM has higher, greater storage than DRAM. Static RAM takes less power to perform. Static RAM takes less power to perform. Disadvantages of static RAM. Static RAM has less memory capacity. Static RAM has high cost of manufacturing than DRAM. Static RAM comprises of more complex design. Static RAM is very costly than DRAM because the building block in static RAM is transistors, which are more costlier than the capacitors, which are the building block of DRAM. Next memory comes dynamic random access memory. Data in the DRAM is stored in the form of capacitors. Capacitors that store data in DRAM gradually discharge energy. No energy means the data has been lost. So a periodic refresh of power is required in order to function. DRAM is called dynamic as constant change or action. Change is continuously happening. Refreshing is needed to keep the data intact. It is used to implement main memory. Advantages of DRAM. Dynamic RAM is slower in comparison to SRAM. Dynamic RAM has low cost of manufacturing than SRAM. Dynamic RAM has greater memory capacities. But there are some disadvantages of dynamic RAM. Dynamic RAM has a slow access speed. It means CPU access data from dynamic RAM slower as compared to SRAM. Dynamic RAM has higher power consumption because refreshing mechanism required. Dynamic RAM data can be lost in case of power loss. Refreshing is needed to keep the data intact. Next, a portion of main memory is also known as ROM. A portion of memory may be constructed with ROM. ROM is read-only chips, read-only memory. The ROM portion of main memory is needed for storing an initial program called a bootstrap loader. When we power on the system, the booting process goes on after the post implemented. In booting, the control program of the operating system is copied or loaded from hard disk to main memory, and the loading of the control program is done by a program that is bootstrap loader, and that program is stored inside the ROM. Next is again auxiliary memory. Auxiliary memory devices used in computer system are magnetic disks and tapes. As I already told, the magnetic disk is a circular plate constructed of metal or plastic coated with magnetized materials. Often both sides of disk can be used and several disks may be stacked on one spindle with read-write heads available on each surface. All disks rotate together at high speed and are not stopped or started for access purposes. Bits are stored in the magnetized surface in spots along concentric circles called tracks. Tracks are commonly divided into further some sections that are known as sectors. So the magnetic tapes and magnetic disks, magnetic drums, all are known as auxiliary memory or secondary memory, and that these memories are used for backup purposes. Here huge amount of data can be stored for longer time. Data can be stored permanently. Data cannot be lost if the power goes. That is the advantage of auxiliary memory. Then next come cache memory. Analysis of a large number of typical program has shown that references to memory at a given interval of time tend to be confined within a few localized area in memory. This phenomena is known as the property of locality of reference. It means 90% of time CPU only access the 10% of segment of instructions. That instructions are preferably arranged in cache memory, that is known as locality of reference. The fundamental idea of cache organization is that by keeping the most frequently accessed instructions and data in the fast cache memory, age memory access time will approach the access time of cache in the fast cache memory. Cache memory performance can be measured in terms of hit ratio. When the data required by the CPU is found in the word cache, it is said to be produced a hit. But if the data is not found in cache, it is in the main memory, it counts as miss. Hit ratio, the ratio of the number of hits divided by the total CPU references to the memory. Total CPU references mean hits plus misses. It is known as hit ratio. Basically, the performance of cache memory is calculated in terms of hit ratio. Again, further, some data which is not in the cache memory can be transferred from main memory to cache memory. So the transformation of data from main memory to cache memory is referred to as a mapping process. Thank you. In next lecture, we will discuss the topic virtual memory.